So the big picture for this lesson is Demoirve's theorem. Demoirve's theorem says that if you have a complex number in polar form or trig form, and n is a positive integer, then if you raise that number to a power, what you do is you can raise the whole thing to the n power, but you can also write it this way: r to the n power cosine n theta plus I sine n theta. So here's an example of using Demoirve's theorem to raise a complex number to a power. So first what you do is you write the number in trigonometric form, find the modulus, or the absolute value. So in this case, it's r equals square root of 1 squared plus square root of 3 squared, which simplifies to 2. That's the modulus. And then theta is 5 pi over 3 because b over a is negative square root of 3 over 1. The reference angle is pi over 3, but because it's in quadrant 4, that makes 5 pi over 3. So then to write the number in trigonometric or polar form, it's z equals 2 times cosine of 5 pi over 3 plus I sine 5 pi over 3. So then you raise it to the 8th power, and then you substitute into Demoirve's theorem. So what happens is you get z to the 8th equals 2 to the 8th times cosine of 8 times 5 pi over 3 plus I sine of 8 times 5 pi over 3. And that simplifies to 40 pi over 3 inside the cosine and sine. And then you find the value in the first rotation of the unit circle, which is 4 pi over 3. That's the equivalent angle there. So then it's z to the 8th equals 2 to the 8th cosine 4 pi over 3 plus I sine 4 pi over 3. You go ahead and find the trig ratios, and it's negative 1/2, and then negative square root of 3 over 2i. And then you distribute the 2 to the 8th and simplify, and you get negative 128 minus 128i squared root 3. So that is how you take a complex number and raise it to a power using Demoirve's theorem. And that's the big picture for this lesson.